All right, guys, so what's going to happen with the lesson videos that I make is that, like, for instance, what I have up right now is the warm-up. And so I want you to try and attempt to do the warm-up on your own, and I'll start by going over it. Anytime I say try this on your own, I'm going to give you a couple seconds so you can pause the video. You can try it on your own and then start playing the video again so you can see the solution to it. Okay, it's going to take self-discipline on your part, but that's the best way it's going to work for you to learn the material, is to try things on your own before looking at the answer. All right, so you could pause here, take time to do these 4 problems for the warm-up. All right, now I'm going to go over the warm-up. We just need to factor. This is stuff that we have done before, okay? With this one, I looked at this one first and thought I was dealing with a perfect square. So I started by saying, oh, well, then the first term must be x, and the sign must be minus, and the third term must be 4. But then I caught myself because this one right here, it can't be minus 4 if I get a negative 16, because negative 4 times negative 4 is positive 16. So this is not a perfect square trinomial, and that's the reason why I know it's not. It's because the third term has to be a positive in order for it to be a perfect square trinomial. So then I said, okay, I'm going to use the factoring by grouping to do this one. So I figured out AC was negative 16. Let me write that a little better. Negative 16. And the B value is negative 6. So 2 numbers that I could multiply together to get me negative 16 and add up to negative 6 would be negative 8 and 2. So I'm going to rewrite it. X squared minus 8x plus 2x minus 16. And I'm going to group the first 2 and the last 2 and pull out common factors. So the common factor on the first group is x, and that leaves me with x minus 8. And the common factor on the second 2 is 2, so that leaves me with x minus 8. And that's how I'm going to get the right factors. So one is x minus 8, and the other one is x plus 2. The other thing I want you to notice is that this is set equal to 0. When we actually have equals 0 on these, we can take it one step further and find the solutions. So x minus 8 equals 0. I just take both factors and set them both equal to 0. Oops, I said equals and I wrote it. I didn't mean that. I meant plus 2. So plus 2 equals 0. So that tells me that x is equal to a positive 8 or x is equal to a negative 2. So I didn't just factor it, I also solved it. So truthfully, if the direction is just factor, then I can leave it right there. I don't have to find out what the zeros are. Now the second one does follow a pattern. It is a perfect square and a perfect square, and we want this one to be separated by subtraction because we only have the 2 terms. So this is actually the difference of 2 perfect squares. The pattern that follows is 2 factors where one is plus and the other one is minus. And we take the square root of 9x squared and get 3x. And we take the square root of 16 and get 4. So this is the answer to factoring. If I wanted to take it one step further and find the zeros, I can do that. So 3x equals negative 4, x equals negative 4 thirds. Over here, 3x minus 4 equals 0. Add 4 to both sides, 3x equals 4, and divide by 3. X equals 4 thirds. Those would be my 2 zeros, a negative 4 thirds and a positive 4 thirds. Now this last one on the screen, I know it's not one of our special cases because it's got a 5. I did glance at it at first and notice it didn't have any common factors to come out. So I'm going to do my grouping. So AC in this case is 5 times negative 4. So it's negative 20. And B is negative 8. All right, so I need 2 numbers that multiply to negative 20 and add up to negative 8. And I come up with negative 10 and positive 2. So I'm going to write 5x squared minus 10x plus 2x minus 4 equals 0. and I'm going to do the grouping. Take out the common factor on the first one, which is 5x, which leaves me x minus 2. Take out the common factor on the second one, which is just 2, and that leaves me x minus 2. So my first factor is x minus 2, and my second factor is the 5x plus 2. So 5x plus 2. Okay, so that is it in factored form. That answers the question that was being asked, but just as a reminder, I could take each one of these a little bit further and find out what the solutions are. Equals 2, and 5x plus 2 equals 0 would get me that 5x equaled negative 2, and dividing both sides by 5, x would be negative 2 fifths. Okay. Next, what we need to do, this problem down here wanted you to focus on order of operations, basically. It tells me I can pick any x value as long as it falls between 1 and 10. So I just randomly picked the number 2. So I said, okay, x is going to equal 2. So everywhere I saw an x, I replaced it with a 2. So I have 2 squared plus 6 times 2 plus 8 over 2 plus 4. Now, the fraction bar works as a grouping symbol. So what that means is I have to do everything on top and then everything on bottom before I actually do the division. So the top, I have an exponent, I have multiplication, and I have addition. So I'm going to do the exponent first. That gets me 4 plus 6 times 2 plus 8. On the bottom, I only have the one operation of addition, so I can do that, and that's 6. The next thing I'm going to do on top is actually this multiplication. So I have 4 plus 12 plus 8 over 6. Okay, and really the last thing I have to do is add all of those pieces together that are in the numerator. So I'm adding 4 and 12 and 8. So I'm getting 24 over 6, and that actually would reduce to 4. Now, if you chose a different number between 1 and 10, you might end up with something different. I just chose 2. I'm not going to go through all the possibilities because, for one, there's an infinite number of values you can pick between 1 and 10. It did not specify it had to be an integer. Okay. All right. So what we're doing today is we're going to be learning about the definition of greatest common factor in order to simplify. We know what a greatest common factor is, so we're pretty good with this already. But we're going to be dealing with rational expression. And what rational, we learned last unit that a rational expression is one that is expressed as a fraction. So we're talking about anything that is of fractional form. It can have just numbers in the numerator and just numbers in the denominator, or we could put variables in the numerator and denominator as well. So what we're going to do is, with these 3 questions, is we're just going to simplify them. They are actually all rationals because they're represented as a fraction. So with just the numbers that are here, what I want to do is I want to look for the greatest common factor. And remember, I told you, if you can't figure it out, you could go to Desmos and type GCF for greatest common factor and put 24 and 40 in parentheses with a comma between them. And Desmos will tell you what the greatest common factor is. The first one that jumps out at me right now is 4, but it's actually more than that. It's actually 8. So what I'm going to do is I'm going to divide both sides by 8. I'm going to factor out an 8. Basically, I'm going to write 8 times 3 is 24, and 8 times 5 is 40. So once I have a match for the top and bottom of something I'm multiplying by, then I can cancel them out. So this is actually 3/5. With the next one, it has variables and also coefficients. I have to do them kind of individually. I have to do the 6 over 10 and then look at the x cubed over the x. Well, 6 and 10 are both divisible by 2, so I'm going to pull that out, and that would leave me with 3x cubed. And in the bottom, that's divisible by 2 as well, so that would leave me 5x. So I've been able to cancel that out. So the fraction I'm dealing with right now is 3x cubed over 5x. Now, you don't have to write that step. I'm just writing it so you can see where it's coming from. So that's as simple as the coefficients go, but now I need to think about the exponents on the variables. So this one's being raised to the third power, and this one's to the first. And when we're dividing variables, what we have to do is subtract their exponents. So when I do the 3 minus the 1, I actually get 3x squared over 5 as the simplified version. Now, when we see a rational expression like this, just like I did factoring first there, I still need to do factoring here, okay? But my factoring will look different because now it's a polynomial. And that's why we were practicing factoring up to this point. I have to bring out the greatest common factor if there is one, and then break it down into the terms. So I do see a greatest common factor in this one. And what I'm going to do is I'm going to shrink this and give myself a lot more room to work with there. Oh, I can't shrink the words, but I got that a little better at least. And I will slide it on over. All right, so what I see is a common factor in this one of 2. Okay, so I'm going to pull that out. 2x squared minus 4x minus 12. I believe this is the minus sign that goes up here. Let's just make sure that that is an object. Yeah. Okay. So I can't factor that. I can't get a greatest common factor out of that anymore. A lot of times I like just simplifying the top as much as I can get it, and then I'll go back and do the bottom. So that's why you'll see I'm just working with the top for now. I need two numbers that multiply to negative 12, but add up to negative 4. I'm thinking negative 6 and positive 2. So I'm saying x minus 6, x plus 2. Okay, so that looks like the numerator. The denominator, I just need two numbers that multiply to 18 and add up to negative 9. So I'm thinking negative 6 and negative 3. So I'm going to write that x minus 6 and x minus 3. You can go through factoring by grouping, but if you've picked up that when you have a leading coefficient of 1, those two numbers that you find out actually lead you right into the factors. So what I have now is x minus 6 and x minus 3 in the denominator. What I'm going to look for is a matched factor in the numerator and the denominator. Okay, it has to be something involved with multiplication. So in other words, I can't just cancel out the 6. I have to cancel out the entire factor. So if I have an x minus 6 in the bottom, I need to find an x minus 6 in the top. And I have that, so I cancel it out. I have an x minus 3 in the bottom. I don't have one of those factors in the top. Okay, so this is as simple as this one will go. So we'll rewrite what's left. And x minus 3. You only have one factor in the bottom. You don't have to put the parentheses around it anymore. Okay, so in order to simplify polynomials, we need to be writing them in factored form. So I'm going to work through these three so you have some good examples. But we're also going to talk about how to restrict the domain. If you remember, the domain is usually your x, or basically in these problems, it's x for the first one, x for the second one, and m's for the last one. And the reason we have restrictions on them is because our variable shows up in the denominator. And remember, our denominators are not allowed to ever equal 0. So that's what is going to drive our restrictions. I'll go back over that in a second. We're just going to work on factoring these real quick. So I see a common factor in this numerator 2x minus 8. I see a common factor of 2, and that leaves me x minus 4. And then in the denominator, I see a common factor of 4. When I divide that out, I get x minus 4. So notice I do have matched factors here, so I can divide those out. And then that leaves me with 2 over 4, which can be simplified to 1/2. So that whole fraction up there actually just equals 1/2. In the second one, I'm going to go ahead and factor the top. I need two numbers that multiply to 8 but add up to 6. So I'm going to use x plus 4 and x plus 2. They multiply to 8 but add to 6. And the denominator only has the one factor, x plus 4. So again, I'm looking for matching factors, and I have that in these two. So it simplifies to x plus 2. All right, and in the third one, I can't simplify the numerator any more than it already is, m plus 2. In the denominator, though, I can factor. I'm looking for two numbers that multiply to negative 16 and add up to negative 6. I think we've already done this one. We have m minus 8 and m plus 2. So one of the things I kind of cheat at is if I've already got a single factor listed, I'm thinking there might be one showing up on the other piece. So if I have m plus 2 in the numerator, I'm probably going to get an m plus 2 in the denominator so that they could cancel out. And that's what happens here. So if you cancel everything out in the numerator and there's nothing left up there, you just put a 1. And then whatever remains in the denominator. Now, as far as restrictions go, like I said, we cannot have the denominator ever equaling 0. So we find the zeros of the denominator. But we find the zeros of the denominator of the original problem, not of the one we've simplified. So if I just looked at the zeros of this denominator, I wouldn't have any. But I know better than that because up here, my factor was x minus 4. So in this case, x cannot equal positive 4. Because if I put positive 4 into this expression, I would have 4 minus 4, which would turn my denominator equal to 0. With the second one, my original denominator is x plus 4. In factored form, it's x plus 4. So I'm being told that x cannot equal negative 4. If I had substituted negative 4 into all these x's, I would end up with 0 in the denominator, which would make it undefined. And for the last one, I actually have two factors in the denominator. So x cannot equal a positive 8 or a negative 2. I can't have either one of those. If I substituted those into the expressions, they would all come out and make my denominator equal to 0, which would make it undefined. Okay? So, like I said, with these being videos, you can always pause. If I'm going to the next slide and you're not ready for the next slide, this is kind of self-paced here. So if you still need time to write something down, you can pause here. We're going to do this with a little bit more difficult ones, and then I'm pretty much going to let you, I'm just going to go through them as if you've already worked them, and then I'm going to put the answers up. Okay? So this one I'll talk through a little bit more. So I'm going to focus right on this first numerator. I need two numbers that multiply to 6 and add up to 7. So I believe that'll be x plus 6 and x plus 1. And in the denominator, I need two numbers that multiply to 12 and add up to 8. And I kind of needed a hint on that one, so I looked at the top to see if there was a hint, and I think I'm using the 6. 6 times what gets me to 12? So x plus 6 and x plus 2. So the 6 times 2 gets me to 12, and 6 plus 2 is the 8. So I know I'm done that right. And I'm going to get rid of the similar factor that's in top and in bottom. And I'll write my simplified fraction, x plus 2. Okay, that's my simplified fraction. And I go back to the original factor, the first place where I factored it, so that I can figure out what my zeros would be that would make this undefined. In other words, x cannot equal negative 6 or negative 2. Okay, so there's the restrictions on your domain, because it asks for that as well. Okay, with the second one, I have a common factor. I think we've already done this one by itself. We actually did this in the beginning, but we didn't have time to talk about the restrictions on the domain with it. So I'll get it back into factored form. This is one we did in the, I think on the second slide. So I'll get it back into factored form, which would be 2. And so that's 4 and that's 12. So x minus 6 and x plus 2. So that would be negative 12 times 2 is 24. And negative 6 plus 2 would be negative 4 times 2 is negative 8. Yes. Okay. I just kind of remultiply them sometimes just to make sure I'm right. And then the second one was multiplies to 18, but adds up to negative 9. So that's my x minus 6 and my x minus 3. So the x minus 6's can go away here. And I'll rewrite the final answer. And it's okay to leave the final answer in factored form unless they tell you otherwise. Okay? And x minus 3. Now notice I can't cancel these x's out. That canceling is being blocked by these parentheses. I'd have to take the entire set of parentheses out, just like I did in the top one. So now I want to look for the restrictions in the domain. Well, the restrictions come from the denominator, so I'm looking at x minus 6. So x cannot equal positive 6. And x minus 3, so it cannot equal positive 3 either. And there's your restrictions. All right, so we've got some more problems to work out here, basically with the same directions the whole time. Okay, so try these two. You can go ahead and pause here while you're trying them and then come back and see what I wrote as answers. All right, here we go. So I'm going to take out a common factor in the numerator. So I can take the 2 out, get x squared plus 8x plus 15. The bottom has a common factor of x. That leaves me x squared plus x minus 30. So now in the numerator, I want to figure out what multiplies to 15 and adds up to 8. And that's going to be x plus 5 and x plus 3. And in the denominator, I need what multiplies to negative 30 and adds up to positive 1. And I believe that's going to be x plus 6 and x minus 5. I hesitated here because nothing was canceling out, and that's fine, actually. They could give you a situation where everything is already simplified, and that's the case here. So the restrictions on my domain are x cannot equal, well, from this factor right there, I get 0. From the second one, I get negative 6. And from the last one, I get positive 5. So there's my restrictions. Second one we've got here, I don't see any common factor in the top. So this one's a little bit more difficult to factor. If I did A, C, that would be 30. And B would be 17. Okay, that's not so bad. That looks like 15 and 2, right? Okay, so if you're using 15 and 2 to factor in the top, then you will end up getting the factors of 3x plus 2 times x plus 5. I'm not going to walk out the factoring for you there because we've done that so much already. The bottom one I need multiplies to negative 20 but adds up to 1. So I'm thinking x plus 5 and x minus 4. We'll do that. Okay, so my x plus 5s can cancel. So I get the simplified 3x plus 2 over x minus 4. And I say my restrictions are going to be from the factored original. So that's going to be negative 5 and positive 4. Okay, let's go ahead and try 2 more. If you aren't done copying, just pause. All right, so here we go with these. You don't necessarily have to break down the 2 and the x. Maybe we'll just leave it like that. That seems like it's about as simple as it can get as 2x. But the bottom does have a common factor. It has a common factor of 4. That will leave us with x plus 1. So I can't really get rid of any of the variable factors, but I could simplify the numbers. Because this 2 is attached through multiplication, it's something I can actually start canceling out. And they're both divisible by 2, so 2 divisible by 2 is 1. 4 divisible by 2 is 2. Looks like I'm getting 1 divided by 2, x plus 1. And my restriction is x cannot equal, and go up to this one, negative 1. All right, and my second one, I see a common factor of 9x in the top. So 9x, when I divide that out, gives me x plus 1. In the bottom, I see a common factor of 2. And when I divide the 2 out, I get x plus 1. Now in this one, the factors canceled out and leave me with 9x over 2, which can't be simplified. But I go back to the factored form and look for the zeros. So x cannot equal negative 1. Okay. All right, so if you're still copying, go ahead and pause. We'll go on to the next set. Go ahead and pause the video, try and write these down, try and do them yourself. I'll give you a second to pause. Okay, so I'm going to go show you the factors that I got for this one. This is page 7. So my factors are x plus 10 and x minus 2. And in the bottom, I get x plus 10 and x plus 1. So these two factors cancel out. And they leave me with x minus 2 over x plus 1. And my restrictions are x cannot equal, go up to the factored form, negative 10 and negative 1. So there's your factored form, simplified, and your restrictions. So for the second one here, excuse me, we have x minus 4 and x minus 3. And in the bottom, we're going to have x plus 6 and x minus 3. And sometimes you'll have the x minus 3 written first. You'll have them written in a different order. It's fine because it's multiplication. And multiplication doesn't matter what order we do it in. These two x minus 3s would cancel and give me x minus 4 over x plus 6 with the restrictions that x cannot equal negative 6 and positive 3. All right, if you're not done writing, again, pause, come back when you're done. Try these two. So you pause right now, give it a shot, and then unpause when you're ready to see the worked solutions. All right. So now I'm going to do the solutions for you. The numerator has a common factor of x, which leaves me x cubed plus 5x. Oops, it's not x cubed. Leaves me x squared. Just like that, x squared plus 5x plus 6. No common factors in the bottom, so I'll just rewrite it. Then I have to factor this x squared plus 5x plus 6. So I'm getting x plus 2 and x plus 3 when I do that. And in the bottom, that's the difference of two perfect squares. So I have x plus 2 and x minus 2. So this is my full factored form. So this is where I'm going to get the restrictions on my domain from. But now I'm going to cancel those, and the numerator will be x times x plus 3 over x minus 2. Like I said, that's where I'm getting my domain from. And I see that x cannot equal negative 2 or positive 2. On the second one on the screen, see a common factor of x in the numerator, which leaves me x squared minus 4. That can be factored further. I don't have a common factor in the bottom, so I'm just going to rewrite it for this step. Now I'm going to factor that x squared minus 4. It's the difference of two perfect squares. So I get x plus 2 and x minus 2. And in the denominator, I believe we're going to have x plus 2 and x minus 1. So right here is where I'm going to pull my domain from. But I can cancel the x plus 2's. So I get x times x minus 2 over x minus 1. Go back and look at that line for my restrictions. I see that x cannot equal negative 2 or positive 1. Okay. So if you're not done writing, go ahead and pause it. Let's try these two. So you write them down, pause the video, come back after you've worked them out or gotten stuck. That's fine too, but at least give it a try. Okay, so now I'm going to go over these. First one multiplies to negative 48, adds up to 2. I'm going to use 6 and 8. It's going to be x plus 8 and x minus 6. That should do it for me. And then the bottom is the difference of two squares. So that's x plus 6 and x minus 6. And you can see that the x minus 6 can go away. We have x plus 8 over x plus 6. We're going to go up here for the restrictions. So x cannot equal negative 6 or positive 6. All right. Well, that's easy to factor. We already did that. So I'm just going to write down the same factors we had in the denominator there. X plus 6, x minus 6, and then I need multiplies to 18 and adds up to negative 9. I believe that's going to be x minus 6 and x minus 3. So the x minus 6 cancel out. We get x plus 6 over x minus 3. Now we can't cancel anything out of here. The only time you can cancel something is when it's being multiplied. Well, there's no multiplication in the top or in the bottom, so I can't cancel anything out there. But I can say that x is not allowed to be positive 6 or positive 3. A lot of times people forget the one that they canceled out because they don't go back to the original factored form of it. They try and just do it from the answer. You do have to go back to the original factored form and count all of them. Okay, so you can pause if you're not done writing it down. We only have 3 more slides. This one and then 2 more. Okay, so take a second, write them down, pause, try them on your own. I'm going to go ahead and put up my answers. X plus 7 is as simple as the top gets. Multiplies to negative 21 but adds to 4, I think will be x plus 7 and x minus 3. So the x plus 7's cancel out. Remember, when it all cancels out on the top, what we can do is just put a 1 there. Okay? And x minus 3 on the bottom. And my restrictions are negative 7 and positive 3. The second fraction, I think the top will be x plus 5 and x plus 1. And the bottom is as simple as it goes. So notice that this is the whole factor in the bottom. I can cancel out the whole factor in the bottom with that one. And I just get x plus 5. I don't have to put the 1 under it. I could, but I don't have to. This one I had to put the 1 in the numerator or else it wouldn't be right. And I go back to the original factored form to get my restriction, so x cannot be negative 1. Okay. So pause if you need to. I'm going to change to the next 2. Okay. Pause here, write them down, and try them. I'm going to go ahead and work them out. So I see a common factor of 2x in the top here. And when I divide that out, I get x plus 5. And in the denominator, I see a common factor of 3x. And that leaves me with x plus 5. Well, this one's kind of cool because not only does the x plus 5 cancel out, but so do the x's. So we really just end up with the, if I write it correctly, we just end up with the fraction 2/3. But we have to go back up here and count the zeros of each factor. I have to look at the 3x. So that would tell me that x could not equal 0. And then the x plus 5 would say it can't equal negative 5. All right, and now a second one. I think we're going to do x minus 5 and x plus 2. That multiplies to negative 10 and adds up to negative 3. And in the bottom, x plus 2 and x minus 1. The x plus 2's can cancel. You get x minus 5 over x minus 1. And our restrictions are going to be negative 2 and positive 1. Okay, pause here if you need a second to write things down. I'm going to go to the next page. All right. I believe this is our last page. Yes. Okay, so I need to factor the top of this one. It's a difference of 2 perfect squares. So we actually have x plus 7 and x minus 7. The denominator does not have a common factor. So I can do the a, c, and the b and factor by grouping. When I do that, I should get 2x minus 1 and x plus 7. So if you didn't get that, you might want to rework your factoring there. I'm not good, like I said before, I'm not going to show the factoring piece because we should be almost experts at that by now. We're going to take out the x plus 7 on both of them. And the numerator becomes x minus 7. And the denominator is 2x minus 1. I go back to that original factored form to get what x cannot be. This one would get me 1/2. Can't be a positive 1/2. This one would say negative 7. So there is simplified and also the restrictions on the domain. The top of this one, that's another one that's going to be a little bit harder to factor because it has a leading coefficient of 3. Okay, so when you do factor it, you should get 3x plus 2 and x plus 5 in the top. And in the bottom, you should be getting x plus 5 and x minus 4. And that lets us get the x plus 5s out of there to simplify to 3x plus 2 over x minus 4. And we'll list our restrictions as negative 5 and positive 4. All right. Every once in a while, you probably hear me ask if there's any questions because making the videos is a little weird for me. Not having you guys in front of me at some point, or at least even on the Teams meeting. So it's going to take a little getting used to for me. What you're going to do now is you're going to go and do your closure. And your closure is a lot like these questions here. Okay, so I have the closure on my last slide right here. So you can either pause the video here so that you have the closure that you're seeing, or you can just take and turn the video off and go straight into the closure. Okay, I'm not going to put the answers to this one up. I want to see what you get on your own. Okay, so you'll get the closure done so you get your grade for today. And I guess I'll talk at you at the next video.